for joining me today. My name is Yosef Arbiv, and today we are going to talk about OpenTelemetry. OpenTelemetry is getting more and more attention. It is currently the second most active project in CNCF, which is the Cloud Native Computing Foundation. It's only second to Kubernetes, which is the project that CNCF was founded around. And we see more companies that are building products that support OpenTelemetry and more customers asking us about OpenTelemetry. So today we are going to do a quick overview on observability and monitoring in general. We're going to talk about what exactly is OpenTelemetry, what it provides, how you can use it to help you monitor and troubleshoot your applications, and the current status of this project. And I'm going to show you the community demo of OpenTelemetry. First, a little bit about myself. So my name is Yosef Arbiv. I am married to Adi and father of 3 adorable young boys. I'm a group leader at Cisco ET&I, which is the Emerging Technologies and Incubation Group in Cisco. My group is responsible for contributing code to OpenTelemetry and building the SDKs of OpenTelemetry for our customers. And I have 12 years of experience as a software engineer and in different leadership roles. So let's start with observability. What exactly is observability? This is the Wikipedia definition of observability. So observability is a measure of how well the internal state of the system can be inferred from the external outputs of this system. So if we have a system, the system can be in one of many different states. And we can say that the system is observable if you can know exactly in which state the system currently is by looking on the outputs that the system produces, the different signals that the system produces. But how exactly does it relate to software engineering? So if you have a monolith architecture, it is still very relevant. You need to know in which status the system currently is, and you can know it by looking on the different signals that you produce from the system. So usually you would collect metrics, you would collect logs from this monolith, from different components inside the monolith, and you can look on these metrics and logs and understand what exactly is the status of the system, and you can troubleshoot the system in this way. But this becomes critical as more and more companies are moving to microservices architecture. When we are using microservice architecture, we have a lot of new challenges, and observability becomes critical to deal with those challenges. So what are the challenges that we are facing when we are using microservices architecture? The first challenge is modeling the system. Understanding the different states that the system can be in. What are the different services that we are using? Which service participate in each flow of the system can be very hard. So this is the first challenge, understanding what exactly our system looks like. What are the services that are in this system? What are the different states that the system can be in? This is the first challenge. The second challenge is troubleshooting the system. For example, let's say that we have an alert from the system. Let's say that we have too many 500 errors. It can take a lot of time for the development team to understand what exactly is the flow that causes those errors, what are the different services that participate in this flow, and then we have to look into each different microservice and search for if this is the one that is responsible for this error. And the last challenge that I want to talk about is optimizing the system. Let's say you have a customer that complains that a certain flow is not as fast as it should be. Again, it can take a lot of time for the developers to understand which microservice exactly is responsible for this behavior, and only then they can start thinking of how to improve this behavior. So these are our challenges when we are dealing with microservices architecture. In order to deal with those challenges, we have the three pillars of observability. We have metrics, logs, and traces. Metrics tells us what is happening inside our system. Logs tells us why it happens, why certain behavior is happening inside our system, and traces tells us where it happens inside our system. So let's take a deeper look into each one of those signals. The first signal and the most basic signal that almost every software system produces are logs. So logs tell us why something happened inside our system, but there are a couple of things that we need to make sure we understand when we are dealing with microservices architecture. The first thing is that we would like to collect the logs from all of the different microservices into a single aggregator that we can visualize the logs and search the logs easily. The second thing is that we would like to make the logs structured. So the logs are not some random string that every developer can decide what they want to write in, but they have some structure so we can search them efficiently and we can store them efficiently in our system. And the last thing is that we would like to add identifiers into our logs so we can correlate them between the different services and again serve them more efficiently. So request ID, customer ID, transaction ID, and so on are very helpful if we save them inside our logs. The second thing are metrics. So we want to collect different metrics from all of the different microservices that we are using. And those metrics can help us understand what exactly is happening in our system. Again, we would like to collect all of these metrics into a single dashboard. So we have one place that we should look at when we have problems and one place that can send us alerts when the problems happen. And another thing is that we would like to collect metrics from, we would like to collect business metrics and metrics from the application. So for example, here we can see some application metrics such as the latency and how many errors do we have, but we would also like to collect business metrics. So how many transactions do we have? If you have a web store, so how many return transactions? How many checkout transactions? How many items are there in the cart? And so on. And the last thing that I want to talk about in this part of the presentation is the distributed traces. So when we are dealing with distributed systems, we need to talk about distributed traces. A distributed trace tells us the story of a transaction or an event as it propagates through the entire distributed system. This is an example for a distributed trace on a timeline. So each tile here represents a span. A span represents a single unit of work. So in this case, we have operation A that triggered this entire trace. And in order to complete this operation, we had to perform operation B that happens in another service, and then C and D. And then we had operation E. And when operation E ended, the entire trace is completed. This is another example, but this time a graph representation of a distributed trace. So here you can see a checkout operation. You can see the different microservices that participate in this operation. And here each arrow represents a span. So each arrow is a unit of work that happened between those two services. Here you can see how traces help us understand where certain error happened. So you can see that there was an error in this checkout operation, and this visualization helps understand that the error happened in the discount service. So after we see and we take a look on this trace, we can understand where the error happened, and we can go and start looking in the specific logs that can help us troubleshoot this particular error. So that's it for the short introduction. Any questions before we continue to the part on OpenTelemetry? Okay, so if there are no questions, let's continue. And let's talk about OpenTelemetry. So if you will go to the official website of OpenTelemetry, which is opentelemetry.io, you will see this definition of OpenTelemetry. OpenTelemetry is a collection of tools, APIs, and SDKs, and you can use it to instrument, generate, collect, and export telemetry data, which is metrics, logs, and traces. So eventually, OpenTelemetry helps us to generate, collect, and export telemetry data. It does not deal with storing this data and visualizing this data. So we'll talk about this later. So this is a basic architecture of what your application will look like when you're using OpenTelemetry. We have the APIs and SDKs that run as a part of our application. We can also have processors and exporters running inside this application. Then we have the collector. The collector receives the data, processes the data, and exports it to some backend. And then we have the backend, which is not a part of OpenTelemetry, but an external telemetry backend. So let's talk about the different components that OpenTelemetry is built of and provides that you can use. The first element is the specifications. So OpenTelemetry provides specifications of how each data structure should look like, how a metric should look like, what is a trace, what spans are, how should they look like, what are the APIs that each SDK should supply, and how the SDKs should behave. So this is the first thing that OpenTelemetry provides. Then we have the different SDKs for each language. So for each programming language, we'll have an SDK that implements the API for this particular language. Usually we'll have two repositories in OpenTelemetry. We will have the core repository, which contain the API and the SDK themselves that are used to create the telemetry data. So to create span, to create trace, to create metric, and so on. And then we have the contrib repo, which stores extensions such as processors and exporters, and also automatic instrumentations. For some languages, it will be separated into two repositories. So we'll have one repository for automatic instrumentation and the contrib repo, which contains the extensions. So I mentioned automatic instrumentations, but I didn't really explain what it is. So if we take a look again on this distributed trace, you can see that in order to create this trace, we have to go and to get data from a lot of different microservices. So in this case, we have to go into each one of them, into each operation that happens between those microservices, and to create a span for each operation. And then for each span, we'll have to add additional data to this span. So for example, we will need to add the start time, the end time, some metadata on the operation, and we will also have to send the data from the original service to the other service, so we can connect those traces afterwards on our backend. So this is, of course, a lot of work, and we would not like that every developer will have to do it on their own. So OpenTelemetry provides automatic libraries that create those spans automatically for us. So it depends exactly on which language are you using, but generally speaking, you have either a library for each framework or a general OpenTelemetry agent that you can run beside your application, and it instruments your application and add those calls to OpenTelemetry that create those spans automatically for you. So this is another very useful element that OpenTelemetry provides. And those instrumentations can create metrics and traces for us automatically. Another tool that OpenTelemetry provides is the collector. So the collector is built of receivers, processors, and exporters. The receivers are capable of collecting data from different data stores. So it can be the OpenTelemetry instrumentations, and it can be also other data sources that are not part of OpenTelemetry that also produces telemetry data, such as metrics and logs. So these receivers receive the data from different sources, and then we have the processors that process the data. So for example, we can sample the data if we don't want to send all of the data if we have a very heavy production system. So we want to collect only part of the data. So for example, only 1 out of 100 traces or only certain errors from the system. So these are the processors. And then we have the exporters that can send the data to various backends that are supported. So usually we would have an exporter for every protocol or every vendor, so it can send the data in a specific protocol to this vendor. I mentioned earlier that the exporters can also run as a part of your application. So in a different SDK, in a different contrib repos for each language, you have some exporters that you can use inside your application. So when would you like to use the collector? One reason for using the collector is if you want to have better performance in your application. In this case, if you want to reduce the overhead of OpenTelemetry in your application, you can use the collector, and then the application itself does not need to interact with network operations and the processing of the data, but it only sends the data fast to the collector, and the collector deals with the processing and the network operation separately in another process, and maybe when the system has more CPU time. Another reason to use the exporter is if you want to separate your application from the telemetry backend. So, for example, if you have a Kubernetes cluster and you have many different nodes, and you don't want all of this node to be connected to the telemetry backend, you can have all of these nodes send your telemetry data to the collector, which runs on a specific node, and only this collector is connected to the telemetry backend. So the collector can be deployed in two different ways. It can be deployed as an agent running on the same host as your application, or as a gateway on a different host if you want to separate, as I said before, to separate your application from the telemetry backend. Okay, so let's talk about the backend. So we collected a lot of data from our application. So we have now metrics and logs and traces that we are sending, but we want to use them, right? We want to be able to search for them. We want to be able to visualize them and to use them to actually troubleshoot our application. So in order to do that, we have different solutions. The first solution that we can use is the open source stack. There are many open source projects that are being developed for this purpose. So for example, we have Jaeger for traces, we have Prometheus and Grafana for metrics, and so on. So if you want, you can build up your own open source stack and you can run it on your own resources. Another possibility is to use some commercial solutions. You can see the list of vendors that support OpenTelemetry in the OpenTelemetry site. So you can search for different vendors. Many of them have free tiers or open source projects themselves, so you can use them as well. We at Cisco provide the AppDynamics Cloud, which is a cloud-native monitoring and troubleshooting utility that it was released a couple of months ago, and it's currently available. And we are currently working on an open source project for traces visualization and troubleshooting that will be available soon for you to use. So the last thing that I want to talk about regarding OpenTelemetry, what OpenTelemetry provides is the OpenTelemetry community. So the OpenTelemetry community provides documentation. The documentation is not perfect, but it can really help you to onboard with OpenTelemetry and to understand the basics of it. So I really recommend using the OpenTelemetry documentation. It's available online, of course. And then you have the GitHub repositories. So of course, all of the code is available in the GitHub repositories. And you can also take a look on the different issues and bugs and the discussions on them. So it can be very useful. We also have the Slack channels in the CNCF Slack space. We have many different Slack channels that are dedicated for OpenTelemetry and for the different projects inside OpenTelemetry. So this is a great place if you want to ask questions, if you want to search for answers that were previously sent in those channels. So this is a great resource, and I really recommend you join this Slack space of CNCF. And the last thing are SIG meetings. So a SIG is a special interest group, and we have a special interest group for each different project inside OpenTelemetry. This group usually meets once in a week or once in 2 weeks, and this is a great place to talk with the maintainers, to ask them questions, and to see where OpenTelemetry is going. And by the way, all of these SIGs are recorded and published to YouTube automatically, so you can also take a look on previous SIG as well. So now I guess that what you want to ask is, okay, what's the status of OpenTelemetry? Is it ready to use? Is it generally available? Is it released yet? Is it in beta? So the answer to this question is that it depends. OpenTelemetry is built of many different components. We have metrics, logs, and traces for each different programming language. So for each component, we have a different state and different status for each one of them. So it really depends on what exactly do you want to achieve and what technology stack, what frameworks are you currently using. Generally speaking, the traces are stable and generally available for use. The metrics and logs are still in development and in different status for each programming language. So what I recommend in this case is that you check your own stack. What frameworks are you using? What do you want to achieve with OpenTelemetry? Do you want to collect disabled traces? Do you want to collect metrics? And then you can take a look on the current status of OpenTelemetry for your particular stack, and you can understand if it's stable or not. And by the way, for example, metrics are currently still experimental in Python, but they are release candidates. So although it's still considered as experimental, it is relatively very stable, and it will soon be released as stable. So you really need to check the current status for your own frameworks and what are you currently using. The last thing I want to talk about today is the OpenTelemetry community demo. So OpenTelemetry provides a demo as a part of the OpenTelemetry project. This is an example of a web store that it is built on a microservices architecture. You can search for it for telescopes, and here you can see the architecture of this web store. So as you can see, we have many different microservices, and each one of them is built on a different programming language. So we have Java, Go, Python, .NET, and many other languages. And you can use this demo to understand how OpenTelemetry behaves and what does it look like to use OpenTelemetry in each different programming language. This demo is available online. and you can download it to your own laptops and run it on your own laptop, and you can see the different languages, how they are running, and how they interact with the backend. So in addition to the OpenTelemetry services, you have the backend. In this case, we are using Jaeger backend, which you can use to visualize the traces from your system. And you can also use, see metrics from this application, from this web store in Prometheus and Grafana. So bringing up this demo is really easy. It is working with Kubernetes or with Docker. So I really recommend you to look for it and to try to run it on your own computers, so you can really start playing and understanding what is exactly the signals that are being sent from OpenTelemetry, and to start feel it in your own hands. So that's it for today. Thank you very much for joining me. If there are any questions, I'll be happy to take them now. Thank you. Okay, thank you. Yeah. Okay, so OpenTelemetry provides exporter that supports the Prometheus data structures and protocols. So you can search for an example for this, for how to use OpenTelemetry with Prometheus. You can either look on the community demo that is available on OpenTelemetry GitHub project, and you can also look at the documentation of OpenTelemetry online. So it's really available for you, and you can use it, like you can take the example from the community demo or from the documentation, and it's really easy to use. Sure. Are there any other questions? So OpenTelemetry is used to generate and collect different signals from your system. So generally speaking, you can use it either to generate those signals, such as metrics, logs, and traces, and you can also use it to combine those signals with other signals. So you can use the collector to collect different signals from OpenTelemetry and from other sources as well. And then you can send them to some other systems that you're using, some backend system that you're using. Okay, so does this answer your question? Exactly. Yeah, that's right. So I'm not really familiar with Logstash. I can take a look at it afterwards, but generally speaking, yeah, maybe it can be either an alternative for the collection, and maybe there is some kind of integration between the collector and this Logstash. So this can also be a possibility. Yeah, yeah, definitely. So I didn't mention before, but OpenTelemetry was established about 3 or 4 years ago as a merger of two different previous open source project that we're dealing with creating and generating telemetry data. The problem is that when we are using microservice architecture, we have different vendors that provide different services for us, right? So eventually, we would have many different data sources and different standards. And even for us as a company that uses microservice architecture, it can be really hard to start working with a provider that provides some troubleshooting solutions for us, because when we're using this provider, we invest a lot of time in bringing up and bootstrapping our application with this vendor, and then we are locked eventually with this vendor, right? So OpenTelemetry wants to solve this issue. We want to have a unique, a general standard for how telemetry data is produced and how this telemetry data looks like. And then you can have data sent from all of the different services, from different data sources, and this data is in a standard, so it's all standardized. And you can also send it to different vendors. So we have many different vendors that are all using OpenTelemetry, and you can switch between vendors, and you can easily check which vendors provide better value for you. So this is a great value that OpenTelemetry provides. Okay, thank you very much. Okay, bye-bye.